Hello and welcome to the second video in the INAV for Beginners 2023 series. If you haven't already checked out the first one, go and check that one out. That explains what this is all about, why you'd use INAV, but also some tips and tricks for how you're going to set up your radio to use INAV. The radio setup is always the same, irrespective of whether it's a wing, a plane, conventional V-tail, a boat, a car, but also information as well about some tips and tricks for how you can set up the model to make sure that INAV is going to work really well. This time round, it is all about flashing the flight controller, putting INAV, the software, onto the flight controller, the physical circuit board, and also connecting up a GPS and a receiver too, configuring all that on the bench and testing it before it goes into the model. Why do I do it that way? Well, personally, I like to check that the flight controller is okay and will flash up and calibrate before I start soldering things onto it. Major reason for that is that in the unlikely event that I happen to get a dud flight controller, then I can just contact the person I bought it from and send it back. Some of them are very reluctant to receive broken flight controllers that are covered in blobs of solder. Once we have it flashed and set up, then we can figure out where all of the other components connect, and things like the Maytech flight controller that we're using in this series is great. They have a fantastic wiring diagram for that. And then we can run through the rest of the setup. By the end of this, the aim is to have it sat on the bench all working, with the GPS getting a lock, with us able to see the radio controls moving on the flight controller via the configurator on the PC. And then the next step in the next video is then to transfer all those electronics and install them into the model in a way that's going to be secure and will work for the particular model that we're using. Now, the reason that I do it in these two steps is because it can get tricky if you are relatively new to INAV and flight controllers. Trying to figure out where your wiring has gone wrong when you're trying to do all this stuff can get really complicated if you've already run wires and sunk them into foam and glued them in and all kinds of different things. Because once you have it all working on the bench, I just tend to photograph it and document it, and then I know exactly which colours of wires are going to where, and it's then very easy. I'm just plugging everything back in when I've figured out where everything needs to fit. So stay with me, we're going to go through this. Again, this video is aimed absolutely at beginners. It's a little bit longer than normal because I'm going to go through every single step, and I'm going to explain as I go through every single step exactly what that step is about and what your options are and what potentially the danger is if you miss it. So again, I've not soldered anything onto this flight controller at all. The really nice thing about these flight controllers is there's lots of places that you can plug everything in, or called UARTs. We'll talk about that in a moment. And you have this separate little daughter board where you have the USB connector and the buzzer too, which is going to help you find the model. It comes down in long grass. Now, before we do anything with this, we need to get hold of the software. So here in the computer, we're going to download it from the website. Now this is where we need to go. INAV configurator releases. I'll put the link down below. The latest version is 6.1, so you need to download the latest and greatest. If you scroll down, you'll find the assets, and here are them for Linux, Mac OS, Windows, everything else. I'm going to download the zip file for Windows 64. We're going to do the zip file just because that's the easiest way to do it. And then what I'm going to do is I'm just going to open that zip file. I'm going to Control-C to copy everything. And I'm just going to copy it onto the desktop. And while that's copying onto the desktop, then that's all you need to do. You don't need to install it. You don't need to do anything else. When you come to run it, it may give you an error telling you that, something horrible has happened and this is a virus or whatever. Typically, that's just because it's a very new version of the configurator. We might get that in a moment when we go to run it. So as it now on desktop, we can just open the folder, run INAV configurator, and then, there's the warning. We'll say run anyway, just because the computer hasn't seen it before, and then INAV will start, and then we're almost at a stage where we can start playing with stuff. Now I would plug the cable into the flight controller first, and then plug it into the computer, and then should boot up, and when it's booted, we should be able to then go and flash it. So it's appeared on the top at COM5, which is what we want. So we don't want to connect to it and play with stuff. We want to go into firmware flasher, and we'll click on auto select targets, and it's found it. This is the target that we want. If you come in here and it doesn't automatically figure this out, and it might not do if it's in an older version, or some boards don't seem to like it, then most manufacturers will show you what the target needs to be. And you can see here it says it needs to be for INAV Matek F405TE, which is what we've got. So now we know we're on, that's the right target, a different version. And again, you can just go in here and scroll down and find the one that you want. We'll click the latest version of INAV, make sure that full chip arrays is selected. We'll load the firmware online. There's all the release notes, and we'll click Flash Firmware. Now, it should then reboot and everything should start happening. It's erasing, and these three letters should appear at the top, DFU, Device Firmware Update. That should happen automatically. If it doesn't, don't worry. It's just a driver issue that some computers tend to have. Windows in particular, what you need to do is run something called the Zadig or the Impulse RC driver fixer. I'll put a link down below to both of those things. I've made a video on them. They're relatively easy to use. You just plug your flight controller in, reboot it, and then if it doesn't appear, you can run that and it'll assign the right driver. It's pretty foolproof and it's very simple and easy to do. So now we are in DFU, or Device Firmware Update. It means that there's a bootloader now running on the flight controller, and that bootloader then means that it isn't running the main firmware, so we can copy the new firmware on. However, it has finished. We have lots of little flashy lights, which means it's rebooted. Let's click on Connect and start configuring. Now, first thing it's going to ask us to do is what kind of model are you setting this into. We are obviously going to be a wing, an airplane without a tail. So we'll click on that. That is then going to go and set most of the defaults that we need, and then we can go through and do the configuration, the rest of it ourselves, how we want it set up. So now as I move the board around, it'll move on the desk. You can see we actually have it all sorted. So we're going to go through each of the pieces here on the left hand side. We can do this at relatively quick pace. However, I'm going to explain why we need them all. Calibration is going to be the first thing. I recommend doing the calibration before we put the board inside the airplane and start soldering things to it, because at the moment it's easy to hold it flat in all orientations. So what we're going to do is we're going to say I'm going to calibrate the accelerometer. It'll say put it in all the shown positions and click OK. So do that. So I'm going to hold it flat, click calibrate accelerometer, and the one that we've just done should go green and tick. We'll turn it upside down and click calibrate accelerometer. Again, it doesn't have to be bang on in terms of the position, but sometimes it will kind of reset, and you just work your way through in each of these positions, one after the other. Just take your time with this. Once you've done it half a dozen times, it'll be like falling off the proverbial log. And this should be the last one, which has the connector on it. Bingo, there we go. Calibration is done. Click OK, and we'll save and reboot. That's one of the big things done. We should never have to calibrate again, and we can copy that calibration data from the flight controller when we do upgrades in future, which will save us having to do that again. Next one is going to be mixer. It's going to set this up by default because we told it it's going to be a wing. So we just have the two servos. Servo 3 is this wing over here, servo 4, that'll be plugged in into the airplane. We're not going to change any of this. We have one motor output that we're going to plug the motor into, and two servos, and those servos are combining the roll and pitches together. So this is why on the radio we don't do any mixing at all, because all the clever mixing is now done in INAV. In the Outputs tab, this is going to be disabled by default, so there's going to be no signals sent from the flight controller out to the servos or motor. This is the last thing we're going to do, and this is a very common thing I get messages about where things don't work, and it's because this hasn't been turned on. We'll keep the ESC protocol as standard, and we will keep the servo refresh at 50 Hz, which is fine for analog. We're not going to change any of this. We'll play with this once it's all inside the wing. The only thing I do know is because I wrote down the midpoints, you remember when we did the test in the first, we know that servo 3 is 1550, and we know that servo 2 is 470. Call it 470 for the sake of argument. Now we can set it up so that INAV can trim all this stuff when it's flying and set it all for you, but that's a good starting point. Save. Next thing then we're going to do is select the ports. Now these are all these UARTs. This is all these extra little pins on the flight controller are. Universal asynchronous receive and transmit. They're used for different things. Serial 2 is set for the serial receiver. That's where we're going to plug the serial receiver in. That's set by default. Where everything else plugs in can be a bit tricky. You can kind of decide where you want everything. The trick is with this is have a look at the wiring diagrams that come for the flight controller that you've bought. And this is one of the reasons why I love Maytech. Because on the Maytech site, under where it talks about what the target needs to be, it has a wiring diagram and it shows where everything's going to plug in. So there is our GPS and it's going to plug into RX4 and TX4. That means that UART4, which is that number, is going to be our GPS. So UART4, we will say, make that my GPS. And then we need another UART that we want to plug in our on-screen display stuff into. Now down here, there's a teeny weeny note saying the DJI FPV OSD system can work with any spare UART. As this is the front of the model and this is the back, so that you can see here, and there's usually like an arrow pointing towards the front. The cables in my model, I think, are going to end up coming on this side. So having RX3 and TX3 or UART3 would be very handy for that. So let's set UART3 for MSP DisplayPort and click Save and Reboot. And those are the ports that's telling the flight controller where everything is going to be plugged into. And they're incredibly powerful, and it means that having extra spare ports means we can add extra things in later on. In the configuration tab, we're not going to do an awful lot in here. The only thing we're really going to do is we're going to turn on a couple of things. We're going to turn on GPS for navigation and telemetry. Next time we reboot it, it's going to go red in here. And we're also then going to turn on continuously trim servos on fixed wing. That's going to fix those middle positions that we've just set up and just trim them perfectly for us. We're also going to permanently enable launch mode for fixed wing. We'll save and reboot. And that means that I can, as soon as I arm the model, it'll be ready to fly, and I just throw it into the air and it'll catch itself and soar into the sky. It's an incredibly safe way of launching models, and I use it on all of mine. Fail safe, well, we're going to click return to home. That's kind of the whole point of having the GPS connected. You see here that the GPS at the top went red. We'll see that again in a moment. The compass is now, because it knows it has a GPS connected to that UART and it's going to try and use it for navigation, it's trying to talk to the GPS. And when it boots, it'll be sending messages to try and talk to and configure the GPS. Eventually that will fail and we get the little red thing. However, when it's all connected, that should work fine. PID tuning and advanced tuning, I'm not bothered about. Receiver, we just need to make sure it's set for the right thing. We're going to be using Express LRS that's going to be talking to this via CRSF. So that's the right thing. And again, here are all the channels that we've set up. This should match the radio. So we will check this in a moment when we have everything connected. If it isn't the right mapping, you can change it here, but I would just keep it for the default for now, and it's set for CRSF, which is the one we want. The other option commonly used is S-Bus, but CRSF is going to work. Modes tab. Let's play with this for a moment. So we know we set up channel 5 to be the arming. So when the channel 5 value, which is that little blue indicator, is in anywhere where we've just set that range, it's going to arm. In terms of the flight modes, I like to have it for the maiden flight horizon in the low position, manual in the middle position, and acro, i.e. nothing, in the high position. I then like to have a couple of extra things set up. Things like auto level, I have on channel 7, which is what I have on my radio. Make sure you're selecting the right channels. Auto tune, I usually have on channel 8. And then finally, I want my beeper, which will be way down the bottom. There it is, for channel 9. And that is all that stuff done. Let's just make sure that's channel 9. We'll double check that when we have everything connected in a moment. We click save. Apart from that, the only thing I might do here is coming to the on-screen display and move all the elements around. Now we have MSP DisplayPort set up for one of the ports. We'll have the options to do all the funky stuff for the different HD systems. I'm going to install the walk snail system into the nose of this baby AR Wing Pro. So let's just select that, avatar, and then we can drag all the pieces around. But apart from that, I think we're in a pretty good state. So let me save that, and then we'll disconnect. what we'll do is, now we have everything sorted, is we'll unplug the flight controller, and I can now solder the pins on. I'm going to solder pins here for the connectors for the 2 servos in the wing. I'm also then going to solder on the connections for the OSD stuff and also for the receiver. I'm probably going to actually solder the GPS directly on. So here we have everything all connected together. What I've done is I have installed a couple of pins here. That is on TX3 and RX3. They're going to be the UART that's going to connect up for the on-screen display. We'll sort that out in the next video. Then here I've connected pins. This is only because this is a beta FPV diversity. It's a Super D diversity, and it is connecting via these 4 cables into this, and it means that I can swap it around later if I want to play. And then I have had a rough idea of where the GPS and flight controller will need to go, just kind of eyeballed it and put these 2 together. Now I've soldered them together. The only thing I've had to make sure is that the ground wire that's here on the GPS goes to the ground wire on the flight controller. The 4.5 volts goes to the 5 volts, and then the transmit pin on the GPS goes to the receive pin on the flight controller, and vice versa. That's all the soldering I've done on the top. On the bottom, I've done a couple of extra things as well. This is the lower part of the board. What I've done is I have installed the pins that are going to plug in to the servos. This is going to need all tightening up when I put it all back together. The other thing that I've done is I have installed a power lead. The reason I've installed the power lead is sometimes these flight controllers need a battery plugged in order to power things like the GPS and the receiver, and that means that unless you have a battery plugged in, you can't test them on the bench. And the only other thing I've done is I've tinned the other pads. That's the ground and the positive pad for the ESC, and those other 2 that hopefully you can see it on the camera are the ground and signal wire for the ESC that we'll do when we get to the next step. So all I need to do now is to gently, with the pins aligned, push these 2 boards back together and do up the screws, and we can plug it back into the computer and check that things like the GPS work and the receiver works too. So let's fire up the computer and do that next. So here on the computer, I've got INAV ready to go. Let's plug it in. Now, if you're ever going to power a flight controller from the battery, I would always use something like a smoke stopper for the first time. These are incredibly useful. Make sure that nothing nasty happens, but also double check over the pins that there is no dead short. Now, we're probably going to do that next time because I think this Maytech board is probably going to behave nicely. One of the reasons why I like the Maytech boards, and it's going to power both the Express LRS receiver and also hopefully the GPS as well, and we can just test both are working. Now what I'm going to do is I'm going to turn on my radio and power that on.
Welcome to Edge TX.
And with the radio powered, I'm going to plug the USB cable into the computer. After triple checking, all the wiring is good. That looks very promising. We have LEDs all over the place. We have them on the GPS. The receiver looks like it's bound up. Fab. So on the computer, let's click connect. The GPS is now blue. That's fab. If we go to the GPS, it probably hasn't got a GPS lock, but if we look down here, we should see that messages, you can see 120 and no errors. So that means the GPS is absolutely talking to us. It's configured. It's happy. I would probably say auto detect and use Galileo satellites. Let's just save and reboot. That should give us more satellites to have a go at. So that's fab. We know the GPS is powered. It's connected properly. That's a relief because I'd actually soldered that on. Next thing to do then is go into the receiver. In the receiver tab, I need to move the throttle up. So let me just move this stuff out of the way so I can bring in,
Telemetry lost.
there we go, the radio. What I'm going to do is I'm going to raise the throttle. That's very promising. I'm going to lower the throttle, raise and lower the throttle. That looks great. All of the middle channel values are at 1500, which is exactly where you need them to be. If they're not, use the sub trims on the radio to get them exactly to those values. If I put the sticks to the top right hand corner, they all go to their maximum value. Similarly, lower left hand corner, they go to the minimum value. Everything is working great. Modes is good. This all looks really happy. So the receiver's good. We know the GPS is working. Everything is fab. So now,
Telemetry lost.
every time I move it, it's losing connection. So there's obviously a dodgy connection somewhere here between the computer and this. But I'm happy now at this point that this is all working. And I can go on to the next stage and we can look at how we're going to get all of this into the model, preserve the center of gravity, activate the outputs, make sure that the controls working in the right direction, they have enough throw, and also things like the motor is working, that we can arm it and do all of those things. So there we have it. We have all of the things set up on the bench and it's ready to go into the model. So join me next time where we will do just that, and we'll have to think about stuff like central gravity and putting things in like the FPV equipment and the battery we want to use, and where that CG is, so where we can put the flight controller, best places for the flight controller and the GPS, and how to put all that stuff in the foam wing that we're using here, the Baby Air Wing Pro. And then we're ready for the final video in the series, which is the maiden flight. So hopefully you've enjoyed that and that's been useful. Join me next time where we'll put all those electronics that we've just set up in the foam. Thank you for watching the video. If you watch my videos and find them useful, then please take a moment to hit the like and subscribe button. It helps the channel a lot. If you really like what I'm doing here, you can become a Patreon and support the time I spend helping others and get access to lots of exclusive benefits. Link is in the video description. Remember that all the videos on the channel are organized into playlists, so you can easily use those playlists to find all the videos on a subject that you are interested in. Add Painless 360 to your searches on Google and YouTube, and it'll help you find my content for any particular topic. Thanks again for watching, and as always, happy flying.